Hello guys, how are you? So after so many days, I am making some videos related to some recent trends in the data science. And as you know, data science is such a vast and huge fields. So each and every day, I can say for each hour, there are some magical changes are happening. And in the recent past, there are some things happens like before 3 or 4 years, there are just most focus are given on the traditional machine learning algorithms such as machine learning, linear regression, logistic regression, and all those. But what happens when you are going to do all those practice and all those? Just wait, I'm sharing screen. So, but in the recent nowadays, what happens? There are huge growths happening in large language models. So I will just give you flow some flow. Like initially, I will just open my VS Code, and it will going to take some time. Okay, no problem. So uh, okay, so I will just going to write some flow here. What's happening and all those. I hope it is going to visualize in the YouTube Studio. So just give me 1 minute. I'm just going to check into the my YouTube app. I don't know now how to check. Okay, I hope it's visible in the VS Code I'm writing, or you can just listen. So initially they were just focused on machine learning. It's a traditional machine learning, and they were just asking this some simple algorithm like linear regression type problems or random forest or XGBoost and all those. So after that, some unsupervised came like k-means clustering, hierarchy clustering, DB scan clustering, and all those. After that, there is some growth and some changes happening like NLP, natural language processing, where they were just giving the focus on count vector or TF-IDF, or you can say forward to vector. And after that, deep learning came. After that, CNN, computer vision, then RNN, LSTM, and there is a huge growth happening in transformer models. Means there is a bloom happen in the industry because of transformer models. In the 2018, it was given. I think in 2017, attention all you need in that paper. So after that, there are so many changes are happens, and there are so many large language models came like GPT, GPT 2, 3, 4, Turbo models, Gemini Vision Pro models, and BART model, and all those Mistral or Llama 1, 2, 3, 4 model. So I want to say you here that you should always try to focus on all those changes in the market conditions, because if you only just going to stick store the one particular resource, and if you are not updating your skills, then you are going to face huge challenges, because there are huge recent technologies, tools, and changes. So I'm just going to talk about LLM. What are LLMs? Those are the large language models trained upon the billions or millions or billions of parameters. If you take the example of bird based model, then it's containing 110 millions of parameters, and if you consider GPT-4 or 3.5 turbo, then they are containing 175 billions of parameters. And but they have some drawbacks of those LLMs. If you find those drawbacks of LLMs, such as, means they are just utilized for general purpose languages meant, but if you want to do all those for the specific task and all those, then you are not going to they will not going to give these particular answers. Means I will just going to give you some use case, like suppose if we want to get the answers related to finance domain or medical domains or legal documents domains, and if you ask the particular questions related to your own data or your own terms and technology, that time those models will not going to give you the answer. So then there are two approaches coming into the pictures. First one is the fine tune those models based upon your specific data. So for those fine tuning models, what requires, for those fine tuning, you required your some data, sample data. You need to create some tags, labels. Suppose if it's related to classification or question answering, then you need to create the data in the question answer format. If it's classification, then you need to create the data in the particular sentence and in which category categories you need to classify like traditional machine learning. But what happens when you are fine tuning the LLM? You require a huge RAM and huge resources. And because of model size, then how model will learn, how you will going to do the hyperparameter tuning, then cost and all those. You cannot do all those fine tuning on your local machines, or though you are doing it on the server, it will require huge RAM and GPU. So you know that Nvidia, how that shares are Nvidia's companies are growing because of they are providing some GPUs and all those. And in the recent shares are Nvidia's companies are growing because of they are providing some GPUs and all those. And in the recent trends, only GPU have very huge importance. And based upon that, there is a already race begins between Amazon or Azure or OpenAI or ChatGPT models. So as a data scientist or as a software engineer, then we have solutions to the fine tuning of those models. So for that, we utilize some QLoRa, quantized version of those LoRa or pipped methods. So those methods are nothing but the parameter efficient fine tuning. So instead of fine tuning those 110 billions of parameters or whole models, we are just fine tuning some specific layers or some specific projections like QQ values of those matrices. If you are confusing those terms, I have already covered so many videos related to those. So what happens when you utilize those QLoRa or pipped config, LoRa config files? You are just fine tuning some parameters. Instead of 110 billion parameters, you are just fine tuning thousands of parameters, and still that model will going to give you the best results and output. So what happens when you do the QLoRa and fine tuning? So you will going to get some weights at the last. So you will going to take the base model as it is as shown in this figure. So this one is the base models, and on that base model you are going to create some adapters. So through that QLoRa or LoRa models, we are creating some adapters and we are connecting those adapters to the those base model. And Q means Q is nothing but the quantized version. So already those models are, most of the models are in the 16-bit transformer models. So in quantized version, you are just converting those 16 bits into the 8 bits or 4 bits. So instead of requiring 100 GB or 500 GB of RAM, you will require only 3 or 4 GB of RAM and it will work very well. Though it will going to reduce this some accuracy like 3 or 4%, but still it will works very well. But taking task and and it's require very huge time and all those, how you will create data, where you will get data and all. Excuse me. So there is a rack system came into the picture, and it's a very nice one. So it's a very simple one actually. I will going to give you explain through this, through the diagram. So actually RAG is nothing but retriever augmented generation system. Suppose if you pick up the any GPT model like GPT 3.5 turbo models, and if you want to do the questions answering based upon your specific data, so how you will do that? Because that GPT-4 model don't know how your domain specific data, and those models are trained on only specific data. So here is RAG came into the pictures. Actually, what we are creating, whatever we have specific data, we are uh, converting those data into the proper format, like handling all those text characters and all those, and chunking those into the better formats, because we cannot pass whole data as to those models, because those models also have some input text limits. So we create some chunks like 2000 or 300 text or tokens, and after that we are passing those to the OpenAI models like Ada 2 or other Hugging Face models. Once those embeddings are created, then we are storing those embeddings. Here you will going to see in the figure. I don't know what happened, why it's not. So in the figure you will going to see here, this is vector source. So initially we are passing documents, then we are creating the chunks. Chunks means the splitting of documents into the smaller parts. Then we are creating some embeddings, and after those embeddings we are storing those embeddings into the vector DB. Vector DB is nothing but where all those vectors are stored. And vectors are nothing but the, for each tokens there are maybe 1500 vectors in different directions. And at the last, what we are doing here, we are actually, if user is asking any particular questions, then we are passing that questions to the vector store, and we are checking the similar relevance text from those vector stores. And once we get the similar those vector stores points vectors, then we are passing those vectors with the context to the large language model, and at the last it will going to give the results, and it's working very well, very nicely. But those are the very simple one, and it's just related to the small documents. But suppose if you have millions of documents, that time what you will do means, suppose if you have created the embeddings, but if user ask any specific query, then model, that vector model will means vector retrieval will going to search through the all those millions of documents. So it's not the proper way, it will going to take huge amount of time. So you have just need to find the different approaches like hybrid search methods, in which you will pass that query and semantic search or embedding search type. So it's will going to give very fast retrieval. Or you can split those millions of documents into the 10 or 100 sections, and based upon that you can utilize query retriever mechanism or query transformer mechanism. And so you can also utilize the query indexing, and through that you create those proper system. So it has a very huge scope in the market, and it's the trending field, and it has a very opportunity. But do you know, apart from that, now there is a one another concept is coming, and it's a multimodal LLM. So those models like geminiprovision and all those models, so along with the text they are also trying to take the images. So initially we are just passing the text data, but now along with the text data we are passing the image data, and model will going to give you the answer based upon those images, what's in that image, what it contains graphs, explain me what graphs, or what is the relation between integers, and it's working very well. So that's the things happening, and it has now tremendous demand and growths in the market. And I want to explain you one tool, it's this Sora. I hope you are seeing the screen, and in the screen it's showing that. So Sora is just launched by OpenAI in the last week, and you know it's just create the video as like human. You cannot differentiate between those videos. So I am just going to their website, and on the Tokyo streets filled with some light, neon, and all those. So it will going to create the video as same like that actually, because the video is connected. But if you visit their website and if you try to run all those, then it's opposite. You cannot differentiate between human videos or the videos created by those Sora model. So it's now working. So and market will going to bloom once again in the industry, and there may be a requirement of so many data scientists, AI engineer, and all those who can utilize those models. Because you know there are so many YouTubers, any OpenAI model or Sora models create such movies or things in the doing all those. So have a nice day. I have got a lot of points. There are a lot of things in the happening in the market. Please try to update your knowledge skills. If you lag in that skills, definitely someone will going to take your skills, and they will going to prefer before you. So competition will always remain constant. So be ready for the war and enjoy your life. So thank you. Bye bye. Have a nice day.